Hi, my name is Sydney, and I'll be presenting on Kallmann syndrome today. So I'll start off with a little bit of background. Kallmann syndrome results from hypogonadotropic hypogonadism, or HH, and this occurs when GnRH, or gonadotrophin-releasing hormone, is not properly secreted from the hypothalamus and therefore doesn't travel to the pituitary gland to stimulate these other hormones. And so we see this right here. This would be an example of hypogonadotropic hypogonadism, because GnRH is not being produced and therefore it's not going to the pituitary gland properly, and it's not stimulating luteinizing hormone, LH, or follicle stimulating hormone, or FSH, and therefore there's an underdevelopment in the gonads. And so that's why we see delayed or absence of puberty with those with Kallmann syndrome. There's also an impaired sense of smell with those with Kallmann syndrome, and that's because the olfactory neurons don't properly migrate over to the olfactory bulb, causing an impaired sense of smell. The mode of inheritance is X-linked recessive pattern of inheritance. The visual to the right does a good job explaining this, and we see that those with an X-linked pattern of inheritance have the affected allele on the X chromosome only. In this case, there's an unaffected mother, but she is a carrier, and that's because on one X chromosome she has this X-linked recessive allele, and on the other one she doesn't, and it's dominant. So in this case, she passed on this X-linked recessive allele to her son, and then he got his other allele, the Y chromosome, from his dad. Of course, the gene cannot be on the Y chromosome and is only on the X, and so unfortunately in this case, the son is affected. For males, they just need this one X chromosome to be affected in order to present the case. However, over here, because the daughter has two X chromosomes, one that's affected and one that does not, she does not carry, or she does carry, but she is not affected with Kallmann syndrome. Over here, the two X chromosomes are both dominant, and therefore she's unaffected and not a carrier. And over here, the son is unaffected and, of course, not a carrier. The prevalence of Kallmann syndrome in males is 1 in 30,000, and in females it is 1 in 120,000. So we see that males are more commonly affected with Kallmann syndrome because of this X-linked pattern of inheritance. Furthermore, there's a third of KS cases that are from familial inheritance, whereas the remaining 2/3 are caused by other mutations. This is an example of a pedigree, so I kind of used a brief family tree of mine to show this. You can see that those that are affected are more commonly males, and so in this case we just have my grandma here that's affected with Kallmann syndrome. Of course, this is all hypothetical, and then we have 1, 2, 3, 4, 5, 6, 7 that are affected males, and so we see this disproportionate effect on males in the case of Kallmann syndrome with this X-linked inheritance. There's also the probabilities of showing if their offspring will be affected. We see that in all the cases it is 50%, except for right here. And so the reason that it's 0% is that because the mother in this case, she does not have a recessive X-linked allele. She is both dominant on her X chromosomes. Over here, although her husband is affected because his X chromosome is affected, he'll pass on, even if he passes on this recessive allele to his daughters, the X chromosome they're getting from the mother is dominant, and so that will not be enough to affect their daughters and their sons, because she, again, is passing on a dominant allele, and then that Y chromosome that they would get from their father is, of course, not affected because it can't be on the Y chromosome. But that is not to say that a daughter could not be a carrier, which is seen in this case where Brittany here is a carrier. Haley is not a carrier and not affected. The responsible gene for Kallmann syndrome, this can occur from a few different genes. However, mutations are most often seen in ANOS1, and this can also be called Kallmann. We also see mutations occur sometimes in CHD7, FGF8, FGFR1, or PROKR2 gene. But for the purpose of this project, I focused on ANOS1 because this is the most common. And so this gene is important for the brain development, and so when we see mutations that occur, this could occur and substitutions or deletions in that genomic code, there is not a proper migration of those olfactory neurons and those GnRH neurons, which is why we see that impaired sense of smell and impaired sexual development. Specifically on this gene, it's located on the short arm of the X chromosome on this XP22.3 region. And so this graphic does a good job overall explaining how the affected mutated ANOS1 gene can cause all these signs and symptoms that we see. And so when the ANOS1 gene is affected, this defects the neurons, specifically the olfactory neurons that we see. And so the olfactory neurons don't properly migrate from the olfactory placode into the olfactory bulb. And so when this doesn't occur, then we see hyposmia, or a decreased sense of smell, or anosmia, or a complete loss of smell. In the case of sexual development issues, this is because the defected neurons that occur from the mutation in ANOS1 decrease the release of the gonadotropin releasing hormone, and this decreases the production of luteinizing hormone, or LH, and follicle stimulating hormone, which further just lowers the overall gonadal function. In males, we see a decreased testosterone, and in females, it's a decreased production of progesterone, which are their sex-specific hormones. So the physical effects that we see in males, it includes a micropenis, undescended testicles, so those are kind of the primary characteristics that we see, and then secondary characteristics include lack of facial hair, armpit hair, and pubic hair, and also their voice doesn't deepen as much. In females, we don't see a start of a menstruation cycle, and so this is called amenorrhea right here. That's what that image is indicating. Their breasts are also underdeveloped, and then there's a lack of armpit and pubic hair for females, and so those are the secondary characteristics. In both sexes, we see an overall lowered growth spurt due to that hypogonadotropic hypogonadism, and then also because of the impaired sexual development, a lot of individuals with Kallmann syndrome experience infertility. There's other less common potential signs and symptoms that we see that aren't always paired with the underdevelopment of sex and the sense of smell, but they can be paired. And so this includes a failure for proper kidney development, bone abnormalities in the phalanges, cleft palate, which is seen in the image below, abnormal eye movement, abnormal tooth development, and then in some cases of Kallmann syndrome, it's been noted that there's bimanual synkinesis, and so that's shown in this image up here as a mirror hand disorder. So if one person, or if one hand moves, the other one mirrors it, and so of course this can cause a lot of problems in just daily activities and frustrations that way. There is numerous genetic testing options. It's kind of broken down into two main categories. The cytogenetic test, this occurs within testing of chromosomal location, and then molecular genetic tests are diving more into some DNA technology within the DNA sequence itself. There is only one main cytogenetic test that was found, and that's the microdeletion FISH test. And then with the molecular genetic tests, there's several. There's the constitutional chromosomal microarray analysis, and then there's several sequence deletion duplication analysis specifically relating to the ANOS1 gene, and then that's the common one, so this, or the Ka1 gene. So these are the same, and then these other genes also work with that analysis. There's also a hormone panel for the hypogonadotropic hypogonadism. There's a hearing loss test because that's what one of the symptoms that we see with those presented with Kallmann syndrome, and then there's just the generic Kallmann syndrome panel. Genetic testing is optional, however, it's recommended to patients with family histories because the risk is higher. Furthermore, those that are seeking infertility treatment have to be tested for KS prior to starting treatment, just to cover that base. Testing typically occurs around puberty because that's when the symptoms and signs would produce, and that concern for KS would be prominent. Early detection, of course, is ideal, so you can kind of target those developmental stages in sexual development early. and it is an expensive treatment between $1,500 and $1,800. And these are my references. If you have any questions, let me know.